Welcome back to Adventures in DevOps. In October, we brought in John Papa to talk about IDEs, Copilot, and critical thinking's place in software development lifecycle. It was a fantastic episode, but we only got so far. To extend on the unanswered questions, we're diving deeper today by questioning hopefully everything. And to do that, I brought in Tudor Girba, CEO of Feenk. Welcome to the show.
Nice to meet you again, and thank you for having me.
We chatted before, and you got into a lot of philosophical aspects of the work we do, knowledge work, not necessarily, hands-on technology. And it was just something that I wanted to share with.
Yes, I'm glad you did.
Humans short-term focused historically, and I think even more recently have a focus of switching to LLM generated software development. And I think realistically, understanding the philosophy and strategy behind how we do software development and really any technical thing is important.
Shouldn't that been the thing all along? Let's put things in perspective. We are building a whole new world on top of this new kind of platform. There's a reasonable amount of responsibility that should come with that. And so should it not be expected of us to spend some reasonable amount of time to understand what is it that we do, to understand the properties of the effects of our work. On the other hand, if you look at what developers actually do, they spend a small portion of their time actually building anything. The vast majority of the time is being spent on reading. Now, today, this is much more accepted. People find themselves, I'm reading because the LLM is doing all the writing, and the only thing I'm doing, I'm reading. Software engineering has fundamentally changed. But the thing is, I got to talk with thousands of developers well before there were any LLMs even in sight. And I asked them, do you agree that you spend more than 50% of your time reading code? And basically, developers were saying yes. Now, this is a fascinating thing because 50% or more is the single largest cost we have. There's nothing larger than that, right? And then I was asking them another question. When was the last time you talked about how you read code? It's a very simple question. What do you mean how to read code? Given that this is the single largest expense we have, if we don't talk about it, this means it is not explicit. But if it's not explicit, it has never been optimized. The single largest cost. So we end up being an industry that starts building a whole new world without actually understanding how it is that we're doing things.
Some companies are in different places on the spectrum, though. Like I've definitely seen in some enterprise organizations, lots of meetings dedicated to not just what color should this button be, but what should the hierarchy of our 1,000 microservice monolith directory or repo should be? Like, should we have a folder called tools and a folder called utilities and a folder called, I don't know, like address management? And those things can be referenced each other. And I've seen a lot of conversations wasted trying to figure out, like seeing that there is a problem with how we've managed our source code and just only slightly grasping that something needs to be different. But those conversations usually don't end well. Like they're based off of a couple of different people, usually with an architect title, discussing or debating on what the optimal directory structure is, but not really have any first principles to get to a reasonable place. It's based off of opinions, and maybe you could do some sort of experimentation. Maybe you put forward a hypothesis that an issue is quickly finding what tools are available in order to utilize them. And then from there, you can do some sort of research. But I find that very rarely happens in practice.
Yeah, so I also find, but I think at least this conversation, right? So what's the structure of the project that does tend to happen. Where it starts to fall back is when people agree and then different projects will still look differently. So that their directory structure will still not be uniform across, even after they make that decision. And the question is, why is that? What do we do when we want to ensure that the system behaves the way we expect it to behave? In fact, hopefully today, most organizations have internalized the idea that you shouldn't release. If there's even one test that is read, we automated the answering of functional questions about our systems. Is this particular functionality working the way we expect it to work? This model works exactly because it is made out of little tiny tools. We call them tests. What are those tests? They're just analysis tools. They take lots of information and they transform into red and green types of signals. And the totality of them helps us build a model of the system that allows us to steer much larger systems, much more complicated types of functionality, much more certainly and much more comfortably.
We've created an invention as far as the software development life cycle goes of how we build and manage sort of the quality gate. And if it really is a mechanism that it sits on top of the foundational layer of the source code we write, we should be utilizing it as a mechanism for driving understanding about what the service or product or platform actually does. But I find in practice, very rarely are tests the driving factor for understanding of what's actually happening. It's always like a after effect. Like it's the way you validate what is there is working in practice. Very few companies are actually using their test, be like, oh, how does this function work? Oh, let me go to the unit test and I'll look at the test and the test will tell me how this function works. Well, I don't think that's usually the process, which is, it seems like in a way, completely unfortunate because if our tests are really built up, if TDD is really what a company is doing, tests are a priceless opportunity to use as an endpoint or an entry point into the understanding process that's being completely eliminated or ignored.
When you go you make it so there's a test which is red, then you go and you fix it. And at some point people say, you clean up, but nobody says, how do you go from the red test to fixing it? And nobody says, like, how do you go from this solution here to the cleaned up solution?
Yeah.
Whatever that is. Those things are left to the imagination of the reader, which is, of course, it's development. So if you go back to why do people read code, is because they want to understand enough to make a choice. Because reality, everybody knows that reality is in the system. It's not in documentation. It's not in people's heads. It's also not in AI summaries, by the way. But
I'm trying to figure out, how does the corollary of how we build tests apply to the change that we should make to our software development process?
So answering any question about the system should be intermediated through deterministic contextual tools. Let's go back to your problem with what's the directory structure of my system.
Yeah,
so
right.
And I imagine I take the directory structure, which is basically going to be a tree. And I imagine I will be building, I can build a grammar. And then I can take that grammar and I run it against all the directories that I have in my system. And therefore, I'm going to have a test. But this is not going to be a functional test. It's going to be a structural test. There are going to be other kinds of questions for which we do not know the answer up front. A case that we worked on, where there was a telecom company having a data pipeline, and their problem was that they worked on it for 3 years and they wanted to optimize it. And 3 years back, it took about 1 day from the moment they had the data until the moment some offers were going to lots of customers that they were having. This was their main marketing data pipeline. And 3 years later, so this was like a big problem because this was a business to consumer business, and reacting, having a 1-day reaction time from an event to an offer, it was very, very long. And the board knew about this, and the CIO demanded this must be much faster. 3 years later, somebody measured, it took exactly 1 day from the moment they had the data until the moment they were sending offers. And so now the question was, what happened in 3 years? Now, this is like a different kind of question. It's a question for which we do not know the answer. We might have potential hypotheses. So in their case, when we asked them, we said, well, what's your hypothesis? Well, we probably are producing too much data, and this is why it takes 1 day. But we don't know why this has not been optimized. So like, where did the effort go? Is still an unknown. So we started with saying, so what is your data pipeline? And they drew for us. We say, draw it on the whiteboard. They didn't have documentation for it. So they drew it on, they drew it on the whiteboard. Sounds funny, but at least they were honest, because there are others that say that they have documentation and it's still wrong. So in this case, right, they draw for us the diagram on the whiteboard, and they drew for us 4 boxes. So now what do? We make it the job of the system to give us back this picture, but this time through a tool that directly reads it from the system. So we started to build this one. Now, in the process, we discovered that in the first box, they had a homegrown domain-specific language, which was actually implemented in Excel, So some like was a very elaborate Excel spreadsheet in which people
Yeah.
were describing their transformations, which were then transpiled into Oracle instructions. In this process, we noticed, yeah, the output of the first box doesn't seem to quite match the input of the second box. It was like in 2 weeks into this project. And we went back to them and says, well, are you sure you don't have something in between the first box and the second box? And they discovered the whole system.
How does that happen in practice? Like what world?
Because we thought, oh, this was so rich. When we saw that, it was really funny. Actually, it was really nice for them to accept that. Yes, right, our understanding was really poor. But I've been having conversation with lots of CTOs, and or CIOs, and they tell me, oh yeah, I can tell you a story about this. How is that normality? Because this shouldn't be normal. But unfortunately, so maybe at that level, maybe it's not the case everywhere, hopefully. But if you go 1, 2 levels deeper, you will find immediately where people tell you that the system is something, but the system is actually something else. And what this leads to is a discrepancy between our mental model and what the system is, our mental model and reality. And so we can, in this situation, we can end up easily, dancing around the fire to make rain happen. Right. So and then we will have debates whether or not we should be dancing clockwise or counterclockwise, and there will be evidence gathered as to why clockwise dancing is actually much better than the counterclockwise to make rain happen. And this is unfortunately the kind of thing that we find ourselves often today. Because why? Because we just don't talk about how do we go from a question about the system to getting the answer to the system.
So I feel like in theory, I agree, there should never happen in practice. But then I think about actual organizations where what you've built, and even more, I think is true today, that you have something that's just unmaintainable because the people who have built it and had the mental model even in their heads, assuming you could maintain it, have long left the company. And often these challenges or these questions that want to be answered by the business of like, why does it take 24 hours or a week or a month to close the sales cycle? Is trying to be driven by someone that's outside of even engineering or wherever the problem is being set up. And then they're applying that process to the rest of the organization to give them back an answer. And the individual engineering teams or organizations or what have you don't have the resources or like time or understanding of the system to actually give a correct answer. And so they're, of course, guessing in some regard. And so I sort of like in practice, I can see this as being a reasonable and almost definitive end conclusion. Every single system we build, if it needs to be in a way self-documenting, because no one on the outside will ever have a correct model. There's whatever the saying is, right? Like all models are wrong, but some are useful. But correct model is obviously more useful than an incorrect one. I'm surprised that for answering questions, more organizations don't actually jump in and do the analysis that's necessary. I feel like in the sales world, or at least in marketing, we see lots of ascribing to the benefits of making an A/B test on a website and seeing how many users clicked buy, and whether or not that actually represents the reality correctly is a whole other question. But we do see them actually even approximating the scientific process in some regard.
Data scientists getting closer to where business decisions happen, so that when people have a question, a tool is being created specifically for that question so that an answer then can be used afterwards. So those, A/B test, that's a little tiny experiment that requires a little tiny tool that will project whatever the answer is, so that the people, the stakeholder, the ones that has the question and knows what to do with the information, can make the choice. It doesn't solve the whole problem. It's not like a magic solution for everything. It just removes the largest amount of noise. And in software engineering right now, because we choose not to talk about how we read code, people miss this enormous opportunity to create value that is much, much cheaper than people believe it is.
Is there a distinction between an expert coming in and being able to apply and know which are the right tools to utilize to find the answer, and a fallacy that the fundamental sort of flaw is the approach that is being taken? And Like I can imagine, let's say we're talking about the performance of a system. I can go out and find tools that are built on your favorite package manager, PyPy or NPM, NuGet, etc., and download one of those, install it into my repository, or pay for an open source or SaaS solution that goes and monitors and instruments my project, business solution, whatever service, and get an answer, and then make decisions based off of that. Is it that the wrong tools exist? Is it that the right tools exist, but we don't know how to apply them? Or is there some fundamental philosophy about how we're building our systems that's flawed, that needs to change?
We definitely do not have a shortage of tools. Right. So that's one observation. The other observation is this idea of developers reading code for the largest part of their work is not new. And the oldest reference to the subject goes back to about the 1979 that I could find. So we have like half a century. So the amount of tools grew, but the problem didn't get solved. It's also obvious that the tools we've built are not solving the problem because we can still observe the effect. So then the question is, why not? We were building the wrong kinds of tools. And by this, I mean, yes, you can go and download a tool from the web, but if you use it as is, then it's like downloading a test from the web and using it as is to ask it about the system that you have. Nobody's doing this because it makes no sense, right? Everybody will say, yes, I will be downloading an engine in which I will be writing my own tests. Why? Because nobody knows what makes my system valuable. It is like this. So if you then inverse the situation and you internalize the skill of building the tool. So this whole idea is based on the premise that building tools is expensive. When this idea of testing came first, I remember talking with people in the 2000, 2001, and would say, yeah, but you cannot apply this one to UI. Well, it turns out you can. Oh, but for real-time systems, you cannot apply any kind of testing. Well, it turns out that you can. So and today we're saying, oh, but this is impossible. How can you possibly build a system that parses a new language very quickly? How can you possibly build an architecture diagram very quickly that is highly specific to exactly our protocols and so on and so forth very quickly?
And you sort of just threw this out there, that we have the tools available, but they're maybe not the right tools. But it's really the cost of implementation or utilizing those, which is problematic. And I think you made a reference to this in your book as well, that realistically, if tools were negligible to generate and create to solve any sort of problem, you would spend all your time first generating the appropriate tool to extract the data that you want, and then just get it generated and then get the data. But we haven't been doing that. And I'm wondering, why did that happen? Is it because the primitives we have, programming languages that we have available? Is it about the interfaces that the hardware exposes to us? Are they just all wrong in some way? And we need to push back the learnings that we've had in the last 20 to 30 years to a lower layer so that the abstractions that we're actually given, the interfaces that are actually available to us, contain the right pieces of information? Or is there some other fundamental problem that we haven't been addressing?
There hasn't been a shortage of exploiting or exploring what languages could be. And for sure, there are some languages that are more inviting than others for scrutiny or make things more available. There is no way to perceive anything inside a system, inside a computer, except through some sort of an interface, which basically means that tools are essential. For tools to be effective, they have to be contextualized to the problem that we have. So it's not just some generic tool that we're downloading, but from somewhere, but something that actually matches our questions about the system at this point in time.
I think there are lots of engineers out there that are every single organization that say, oh yeah, you know what? I will just write. I have a whole repository of scripts that I keep and maintain to solve a particular problem. Or you know what? I'll just generate a CLI to do this thing. And the most common strategy I think is like, there's an engineer working at a company. They feel like they don't have the time or space to solve the real problem that company is facing. So they leave. They start their own quote unquote company. They make a CLI. It does something. Then they release it, and then they wonder why they're not getting any users. But I think they are making tools in some regard. I don't know that they're just not doing that.
Oh, for sure. People are making tools. They're just not making enough of them.
More software. We should have more software.
Absolutely. No, but it's again, if you go back to tests, there was a time when people were writing no tests, and people say, "Oh, I'm going to write some tests," and say, "Well, how many do you have?" 50. Yeah, you probably don't yet have it. You're not yet testing your system, right? So in 2002, there was when TDD by example by Ken Beck was published. How many tests do you need? And does this idea, does it scale to a large system? And in there, towards the end of the book, there is one little case study there which says there was this organization which is called Lifeware, and they were having 4,000 tests. And not only they had 4,000 tests, they had a 500,000 lines of code system. And half of these 500,000 lines of code systems were test code. Half of it. And this was the argument as to why they were saying this was the largest test suite that Ken Beck has ever seen at the time. And this was basically the argument. This is what they knew, that it actually does scale. Now, we actually have the pleasure and the privilege actually to work with Lifeware since a few years. And today they have 170,000 tests. So in 2002, their 4,000 tests ran in 20 minutes, which was a remarkable achievement at the time. And today they have 170,000 tests, and they run in like 10 minutes. They have a 35 million lines of code system, and half of that code is test code. Yes, we didn't have enough tests back in the 2000s. So they are embarked on a new exponential that they are basically exploiting. And yes, we do not have enough of those tools to navigate through our system. What we're saying is, in a reasonable system, you should have thousands at least of things that are being shown to you.
And I'm wondering if we're doing something unique that not everyone's doing, and this sort of points to what you're actually suggesting that companies can do to be effective, or engineering organizations or individual engineers to be effective, or whether or not there's still a flaw in our approach. So I think there's a spectrum on one side, and I think Simon Wardley is to actually get all the credit for thinking about this, like which side of the spectrum are you on? Are you building something totally bespoke, or is it a commodity? Wordly map, right? And I feel like for software engineering, there's usually this rule of three. If you do a thing multiple times, you should think about automating it or refactoring it in some regard. And so when we have a bug or a problem and we have logs and we have to jump in and do something manual, we think about, well, why did this have to be manual? Can we build a tool to expose the answer to the question specifically? And so we have this escalation process in how we write software. We start with logs, and if you have an error in your logs, like a null reference exception or a 500, you say, well, why did this happen? And if you don't have the answer to that question, the first step is to start logging additional stuff. But I think this is where a lot of other companies get stuck or misguided, is that they end up stopping there. But we take the next approach. Inside where those error conditions are, we will wrap that log statement with database queries or other traces where we'll improve the log statement in our source code with that additional data. So the next time that log shows up, it says, oh, here's the problem. But also you may want to know, this was the customer that was impacted. This is how many users they have. This is the sort of request they were making. Here's the other request they made for the last 5 minutes. And here's another query that you can automatically run if you're the unfortunate engineer who got woken up at 2 a.m. in the morning and has to actually investigate this. Just click this link. It will open a UI and automatically have the query execute. And then the process continues. What's at the result of that query, maybe more data, et cetera, et cetera. We call this sort of like dynamic UIs or dynamic queries for on-call support. And I'm wondering if that is well aligned with what you're thinking about.
Absolutely.
What I'll say is that when your source code is more constrained with a bounded context, and a smaller size, you don't need to spend as much time thinking about the complexity that was created by having the incorrect directory structure. So in a way, smaller repositories gave us the benefit of getting to sidestep that particular problem of having the incorrect directory structure, because you could still find whatever you were looking for. You didn't need to have it perfect.
The question is the freedom of having an incorrect directory structure important? In other words, do people need to have a different directory structure because it liberates something, or is just the case that they were not exactly aware if it should be SRC or source? Does it need to be the case that the people that are coming up with the new structure not know what the actual structure should be? How do I make that answer more readily available? But there's another one thing that you mentioned before. You talked about the rule of three. The rule of three says, right, you were saying that if I do it 3 times, that I want to automate it. When it comes to, for example, testing, this rule of 3 is not encouraged.
Oh, for sure not.
No, it says the rule of 1, right? Before I'm going to do anything, I want to see if I can capture it in my hypothesis, right? And now, in order for that to work, right, the rule of 3 was made like this because it was still too expensive to do it. But if I'd done it 3 times, and it's probably that I'll be doing multiple times. Therefore, I need to have the business case before I'm going to invest the time to build the tool so that I amortize it over some longer amount of time.
Well, let's fight about that. Because I think that's totally true. And we can look at the XKCD on like, should I automate based off of the amount of time I save versus the amount of time that would cost to actually perform that activity in ad infinitum. I think the rule of 3 really points to the fact that we don't have a perfect capture of the requirements and can never fully have enough information. And it's like that 3 standard deviation actually tells us that we have enough information so that we know that whatever refactor or change we make or whatever automation we're putting in place best represents the reality to a better degree than if there's just the first time.
And if the problem didn't appear often enough, then I'm not going to be building the tool because it's too expensive to build the tool, and it will just increase the time I need to actually solve the problem that I'm paid for, right?
Yeah.
However, if we can bring the cost of a tool to be lower, so that the constructing the tool and solving the problem is less costly than solving the problem without building the tool, then I will be building tools for every problem. And some of those tools will be reused. Some, most not. For example, I give you an example where this happens. Most of the time when I ask people, so if I give you a problem in the database, what's the first thing you do? Oh, I'm going to write a query. But what is a query, right? What is a query? It's a little tool that takes lots of data and then compresses it to a little smaller data, right? Now, it's really fascinating now to just consider coming back to, what needs to change. So if I take the same developer and say, well, I have a problem in the system, what would you, like in this code, what you will do is that they will start reading. Now, what's the difference? Why one behavior in one place and the other one in the other one? Because the code is also data. Now let's take a quick look at the interface that they do the activities through. So when they are exposed to the database problem, what do they see? They see a database tool with a big query at the top and the data at the bottom. So what you're going to do? Well, you're going to write the query at the top and you're going to see the data at the bottom. It's very interesting, right? When you switch to looking into investigating the code, what do you have? You have a giant text editor. So what are you going to do?
No, use the search functionality. With a magic regex, you regex to find exactly your problem, right?
Yeah, for sure. Because why are not people regexing through their database, by the way? Right? Because it doesn't make sense. Why would you do away? Regex means every line of code has the same meaning, same structure as any other line of code, which is absolutely not true. Code is incredibly structured, and doing it. And by the way, the editor that you're using already has all that information.
Yeah.
But it's hidden in that box that you're not allowed to open. And God forbid, you will actually, get good at what you're doing and not buy off-the-shelf tools that actually don't solve your problems.
I think compiler there is the biggest challenge, that a lot of the information that you want to get at is only exposed after it's been compiled into a binary and gone through the assembly and linking process. And it's only recent languages that have been able to reflect this back into the development experience to have the answer right away. And I'd say, realistically, the thing that is always missing for me is like hitting F12 or F11 or whatever on a keyword or class or whatever, and being able to jump in to understanding what that is. But I totally agree in the aspect where what information is exposed in that way is always much less than I want it to be.
So something
Right.
that would take the Excel and transpile it into this. So you would say, oh, yes, because only the interpreter has it, I don't have access. Yeah, but we could still build a tool that would reverse engineer that whole language and puts it together within the context of the entire pipeline. By the way, on the other side of the spectrum, there was a low-code platform called Pega, and they had 22,000 scripts in there. 22,000 scripts. Pega is advertised as, build faster, and they built fast, except that they built 22,000 scripts, and now they had to reason about them. But Pega has no tool to give you any dependency analysis, and definitely no performance of anything, and definitely no data flows that was going through those. So we had to now reverse engineer that one. But Pega doesn't even have an export properly of their source code. So we took the backup format and reverse engineered the whole thing out of that. So no, the compilers are absolutely not the blockers. It is absolutely possible to build tools much, much faster than people think it is. And there is no excuse not to build those. The only excuse we find is because we refuse to talk about the problem. And because we refuse to talk about the problem, we do not observe the opportunities that are all around us. They exist.
So I think this is where we're a little bit unique, because we try to automate everything that we do to a ridiculous degree. Like when we get a support ticket where a customer is asking a question, that answer we think about not, oh, we have some sort of giant knowledge base that we can throw an LLM at and it can dynamically generate the answer, but realistically, is there a deterministic tool that allows us to directly answer it? And if we don't have that, then we go rule of three. The third time we get a support ticket asking about a piece of information, we end up stacking up the internal process. And we have one for this, actually. We start by adding some code to our existing repository for our service. I think an example is like we frequently got a request, like when a new user gets into our login system that we build for our customers. Why doesn't that user link to an existing user? Like, oh, maybe the email address is different, or maybe the identity provider is a little bit different, et cetera. And we get that question pretty frequently. And on the backside, we started building up an answer to this. We started by making the right database queries so that we could quickly answer. But then when we got more requests, we said, well, a database query isn't sufficient. We should have multiple database queries with multiple, data alignment and understanding how it is cohesive together. And then that wasn't sufficient. So then we exposed it on an endpoint that could be called. And for security reasons, of course, it has to have the right authorization and whatnot. And then we took the last step of exposing it back to our end users. And I feel like we have this capability to think in this way. And I'm just wondering, why isn't that no one else is doing this? Is it that the ROI just doesn't seem like it's high enough? Is that a short-term problem that people are too focused? Or is it like it requires a deep because I feel like a lot of what you're talking about requires a deep understanding of the technical challenges. And the one thing I think you really bring to this conversation is this idea that building new tools is incredibly cheap. And with LLMs, it's disposable software that should be almost free to make happen. So I feel like if anything, we're at the exact right point in time to say that everyone should be doing this to solve every single problem that they have.
Are LLMs essential for this? The answer is no.
Oh, for sure not.
Yeah. So the LLMs help? For sure, yes, right? So, but just don't use the LLM, like you were saying, right? You don't ask the LLM, tell me why this is the case, and then
use it to build the tool.
And then you get your proposal, and then you can investigate the tool, because now the bias because whatever the LLM says, it's an opinion. It's just like how your colleague says it's an opinion. So you take the opinion and then you externalize the opinion, you externalize the bias, you can investigate it. You can investigate it yourself and then decide whether or not you're going to delegate to that deterministic tool. Right now, you mentioned why is it the case. So the geekiest detail in the whole of software engineering, that is how does code go from a commit to a deployment? Like, who cares? Like, duh. It's like, this is like the most boring possible thing in the whole of software, right? But it turns out that if you go from a manual solution to an automated solution, you can create $1 trillion worth of economy, which is like, wow, that's kind of interesting, right? But if in your organization that now does manual deployment and you just make it now automatic completely overnight, but you don't change anything else, you will get some benefits, but they will be marginal. If you want to get to the real leaps, you have to change all the processes that happen on top of it. because basically these manual deployments, they introduced delays, then they created unnecessary processes that should disappear basically overnight when this transition happens, because now all of a sudden the deployment becomes from a manual, a customly produced artifact to a commodity, and therefore, coming back to the wordy map, it creates a whole new space on the top left. Okay.
In reading the book and also our conversation here, that one of the problems I think we have is that the construct that we have to store our tools or our toolkits is so inflated with things that have nothing to do with the process in which we evaluate or get answers to questions that we ask. I think of systems where you have, or an organization that has hundreds of thousands of scripts that they can run. Finding the right script at that moment is a challenge in a lot of different ways. And even as you think about like, how can we optimize this to find the right script, you're building a system on top of that, which has its own complexities and challenges in a way. And it's like, in a way, turtles all the way down. And I don't think it's getting any better in any regard. And then you end up with whole organizations and companies that are dedicated just to building the tools to be able to interrogate the database or be provided to engineering team to be able to answer the questions. And I don't know that we have a very mature response to how to deal with package management, I think, in the world. I mean, it's not great. There's still like dependency change and diamond dependency problems and supply chain attacks and S-bombs, like the bill of materials. But I think when it comes to the tools, I think there's like a whole space here that is so poorly managed as far as how to do this, other than, oh yeah, we have a repository with a bunch of things in it.
That's right. What if I can treat the data pipeline problem to be the same as the observability problem, to be the same as the email linking to the user problem? Because this goes quite against the industry, where the data pipeline problem is a $1 billion vertical, and the observability problem is another $1 billion vertical, and the other ones. And there will be all sorts of verticals with $1 billion worth of tool vendors offering you off-the-shelf solutions. Our view is, well, all of these propositions are based on the idea that tools are expensive to build. Well, what if tools are not expensive to build, and that you can have an environment where you can approach arbitrary problems in the same way or in a uniform fashion, and therefore you can internalize the skill once and then build a uniform environment where you're just hosting all of these perspectives.
What is the smallest change to the software development workflow or reality even that would cause us to be pushed in the right direction? Is this a matter of having an integrated development environment like our IDE, or just say like, Visual Studio Code or something else, whatever, using Writer, etc., to have some fundamental difference on how information is exposed to a technical end user? Or is there something fundamental that is there a change in the way we build software products that has to be considered? Is there, the connection? Is it some other primitive? Like what is the first thing that really would need to change? And we can see the output from, like, not just, change your mindset, but specifically some artifact that would prove we're on the right place.
We want an IDE. We need that integrated experience, but the current ones fail quite dramatically. What I'm proposing is not an increment. Spend 15 minutes per day, during your coffee break, just starting the conversation. How do we read code? That's it. This is where it starts. Make it a subject of conversation. Before you even accept that this is a problem, there's no way we're going to make no amount of tooling will change anything. That's the simplest change. And today, right, especially, we can take this opportunity that the LLM brought to actually make it a subject conversation, because finally people recognize that they have to read code for most of their time, and that they also accept that it is annoying, that they shouldn't be reading code. And yes, they shouldn't be reading code to the extent that they do.
I think, as even going further and saying, and maybe this is too much of a shill, that the first few chapters of the moldable development, the rewilding software engineering book that you've written with Simon Wardley, is definitely can be provided as an eye-opening experience for how wrong, some companies are really doing it. And you have some like absolute great examples in there. And like, the example that I'm thinking about is the one with the silicon die hardware manufacturer that you had.
So that was actually the first time when we saw this idea work at scale. So the story goes like this. It's one of the companies, it's a reasonably large companies. I mean, they are not allowed, for example, to trade with China today. So reasonably important. And they build wafer technology. So the factories that produce, that manipulate wafers, they basically build these rooms, and they work with Nobel laureates in chemistry and physics. And this is like an amazing place to be and to visit. It's absolutely an experience. But these robots, these rooms, right? They have these robot arms that are manipulating, often like what is worth like $1 million worth of material inside, and they have to be they have to be controlled in some way, and they use a distributed system for that. And that distributed system relied on a protocol, and they didn't know how that protocol worked anymore. And they gave us this challenge. We were doing it as a research project for them, and so they gave us the sources. And the idea was, take a mesh of nodes written in their technology, and then basically put another node written in another language to show that you can communicate following the same protocol. And so a month later, which is usually how session like meetings are set, you have a cadence of things. So a month later, people say, "Okay, are you ready to start?" And then we said, "Well, we are done." And so, "Well, what do you mean you're done?" So we showed them, "Yeah, here's a new node," and they communicate, and say, "Yeah, but how could you be done? Because we had this bets inside the company saying that there's no way you can do it in a year." They gave us a year to look into the problem because we have no idea how we could do it. And they said, "Yeah." And then they asked us, "So how did you do it?" Well, basically, we spent 3 weeks building a debugger for to figure out your protocol, and then another week to actually, implement the rest of the thing, and that's it. It's that simple. The solution is much less expensive than people believe it is. It's very, very powerful. Computation can be powerful, but you cannot perceive anything inside the computation except through a tool, which makes the tool fundamental. If you change the tool, you change your perception. If you change your perception, you change the way you think. And applies, by the way, also to the new world of AI, right? Don't use AI through standard tools.
There's a lot of great arguments against LLMs that I just don't think people bring up, and this one is one of my favorites for sure. The other one that comes to mind fundamentally is that, oh yeah, humans are computational units, and so are LLMs. So therefore, anything a human can do, an LLM can do, and so obviously LLMs are going to be better in the future. And I'm like, you don't even know where the future of humans are going, let alone that they're computational units. So like, whole argument is flawed, honestly. But before we get to too much philosophy into LLMs, I think maybe this is the moment we shift over to the end of the episode. Let's move over to picks. So Tudor, what did you bring for the audience today?
I spent a week in Normandy with my family, and we visited the D-Day beaches, and it was very impressive. Of course, I mean, the human side of things is the thing that captures the attention there. But if you spend enough time there, there are all sorts of, you get to see the magnitude of the engineering effort, the engineering and research effort that had to all come together for this massive undertaking to actually be possible. I found that to be mind-boggling. I knew about some of it, but taking the time to be there and see it, I was unprepared for that impression. And all the way to the details of, how do you build a bridge over water, which was not a thing that was possible before, in a short amount of time, with not too skilled people, or without having too super specialized equipment there? Or how do you build the whole artificial port in a matter of days, right? All of these questions were just not known just a couple of years before. Yeah, I found that to be absolutely impressive, and is also a really interesting testament of what we can do as a human species when we put our mind to it.
I think there's something actually quite amazing about the beaches, and the one thing that comes to mind is, can you, like, not you, because obviously you visited there and you probably know the answer, but just, you may know that landing on the beaches was basically the end of the war. But why? How did landing on the beaches in Normandy cause the end of the war? Like, what is the connection there? How, like, Germany's on the other side. What does that have to do? How does that impact the army realistically? And I find that as soon as you ask that question, there's so many gaps there in on what's actually happened from a, not just military strategy, but also human strategy, that you really have to wonder, like, what do you actually know about the history? And I feel like it is one thing that's often left out of the history books, that is actually talked about, not just the scale, but the feats that had to go in, and why it was so important for that location to be picked in order to counterattack. So I love your pick. Is there like a particular set of museums or location or tour map that you would suggest to people that maybe we can share a link for in case anyone else is interested?
Time it took a week to visit the entirety. I think the size is only, I don't know if there's any one particular thing that was, a must visit. I just found the size of it.
Yeah,
how did you visit everything?
No, how do you know what everything is? Like, did you do like a lot of background research first?
Oh, there are good sites, and so the official French sites are very thorough. So
okay,
you get an idea. You get a good idea about that.
Okay. I love it. Well, my pick is going to pale in comparison. There were definitely a few different things I was inspired to share, and maybe there'll be future picks related on the topic. But for this, I have something totally unrelated, and that is well, I don't know if I can really claim it's the condiment, but I was a huge fan of the Hoi Fong sriracha, the red sauce with the rooster on it with the green top, bottled in California. And there was actually such a controversy that happened basically at the pandemic, where it got worse. It disappeared and got worse, and it's never really recovered. And I don't want to spoil too much about what actually happened there, but I will say they were getting their peppers from from a grower, and they had a pretty sweet deal. And they switched growers basically. And the original grower of the jalapenos that were being used for sriracha started bottling their own sauce. And so if you want the authentic sriracha, it's out there. Underwood Ranch. That's the company that was making it, and go to town, and there'll be a link in the description, because I absolutely love the original sriracha. That was my go-to hot sauce.
Good to know.
Yeah, I mean, I am super into hot sauces, and I could probably have,
I can see
10 more picks of different hot sauces, and I've had to go out and sort of expand my repertoire after the pandemic, because it had so far gone downhill that it's sometimes not even worth getting. And it's actually the reason why you see so many counterfeits show up now in quite popular style, because I think the biggest one is there's golden dragon, and then there's flying goose is the other one. They're always like a adjective or gerund with an animal associated with it, and they're just not the same.
I understand.
Well, thank you, Tudor, for coming on and walking us through this whole new mental model of software development. I think it's great and something that everyone can go and check out and read up more on.
Well, thank you for your time. I really enjoyed it.
Yeah, so that's moldable development and it's rewilding engineering.
So moldabledevelopment.com is the site where you can read about rewilding software engineering. That's the book that Simon and I are writing.
And the links for this will be in the description for the episode for anyone that's interested. And you may have spotted a hint that in the future we're hoping to have an episode with an expert on formal verification of software, which I think is very interesting and required, but we're still looking for the appropriate expert to come on and talk with us about that. So if you're listening to this episode and know the right person, please forward them along so we can do a deep dive on that. And I just want to thank all of the listeners for tuning in for this week's episode, and hopefully we'll see you all back again next week.